All right, let's dive right in. We're on the hunt for a hidden code. I mean, a real blueprint that secretly designs our world, from incredible architecture to, the music we listen to. But here's the catch. This code is written in a language that seems, well, kind of nuts at first. A language of irrational numbers.
So, let me ask you a question. What on earth could possibly connect the ancient Parthenon, a perfectly tuned piano, and the money growing in your bank account? It sounds like a riddle, I know, but trust me, they all share one fundamental and pretty mind-blowing secret.
Okay, so to crack this code, we have to start with the basics. Every single number you can think of belongs to one of two families. It's like two different kinds of code. You got your rational numbers, they're neat, they're predictable. And then you have their wild, mysterious, and honestly, way more interesting cousins, the irrationals.
Let's break this down. Think about baking a pizza. A rational number is like the recipe calling for 3/4 cup of flour. See? It's a clean, simple fraction. You can write it down, you can measure it perfectly. But an irrational number, that's like pi. Pi describes something totally real, right? The relationship between a circle's edge and its width, but you can never write it down as a neat little fraction. Its decimal just goes on, forever, without ever repeating. It's wild.
Okay, check out this flowchart. It looks complicated, but it's not. Just start at the top with any number. Now you ask one simple question. Can I write this thing as a fraction? If the answer is yes, like for 0.75, that's just 3/4, you follow that path and, boom, you've got a rational number. But if the answer is no, like for pi, well, you take the other path, and you've just entered the world of the irrationals. It's that one little fork in the road that makes all the difference.
So, here's the bottom line. Rational numbers, you can write them as a fraction. Their decimals either stop or they repeat in a nice neat pattern, like 0.333, which we all know is just 1/3. Irrational numbers, though, no way. You can't write them as a simple fraction, and their decimals are this endless, chaotic stream of digits that never, ever repeats. This is where the heavy hitters live: pi, the square root of 2, and even the letter e.
All right, that's enough theory. Let's see this hidden code in the real world. First stop, architecture. We're about to find out how these seemingly messy, chaotic numbers are actually the secret blueprint for some of the most perfect buildings ever made.
And I'm not kidding. Architects use irrational numbers all the time. This isn't just some dusty old math problem. These are actual design tools. This worksheet here shows it perfectly. You've got calculations for domes using pi, rooms designed with the golden ratio. This is the math that turns a drawing into a real, beautiful building.
So let's try one. You're an architect, and you're designing a huge dome that's 30 meters wide. To figure out the distance around it, which is a pretty important measurement, right, you have to use pi. There is no other way to get it exactly right. You can't just estimate it. So the perfect answer, mathematically, is just 30 times pi. But for the folks actually building it, that comes out to about 94.25 meters. Now stop and think about that for a second. That's a real physical length you can walk, and it's dictated by a number that literally goes on forever. That's the magic right there.
Okay, here's another one you'd see all the time. You've got a square window, and you know the diagonal from corner to corner is exactly 2 meters. So, how long is each side? To solve that, you're going to have to dust off the old Pythagorean theorem, and when you do, you'll run straight into another famous irrational number, the square root of 2.
And this, right here, this is the big idea. Just picture a perfect square floor tile, 1 foot by 1 foot. The diagonal line that cuts across it, that's a real thing. It has a real physical length. You can trace it with your finger. And its exact length is the square root of 2. But our number system can never actually write it down perfectly as a decimal. It's a perfect, real thing that our own numbers can only ever get close to.
Okay, let's switch gears. We're going from the world of sight to the world of sound. Because it turns out, the music you love, those harmonies that just give you chills, yeah, they're also built on a secret, irrational foundation. It's incredible. You ever wonder how a piano can sound perfectly in tune no matter what song you play, no matter what key it's in? Well, the secret isn't just good craftsmanship, it's math. A very, very specific and kind of weird irrational number. So here was the problem for centuries. If you tried to tune a piano using nice, simple fractions, rational numbers, it would be a total mess. It's like having a wrench that only fits a few of the bolts on a machine. Sure, a song in one key might sound okay, but then you switch to another key and it would just sound awful, totally out of tune. And the solution is just beautiful. It's the 12th root of 2. It's this one specific irrational number that creates a perfectly even proportional jump between every single note on the piano. This is what allows musicians to slide from one key to another seamlessly and have everything sound perfectly harmonious. It's just amazing.
So we've done architecture, we've done music. Now let's talk about something that hits close to home for all of us: money. Because it turns out that the secret to how things grow naturally, we're talking everything from bacteria in a lab to the balance in your savings account, is all governed by one very special irrational number.
Whenever we talk about compound interest, we're really talking about the power of natural, exponential growth. And it turns out there's an engine that drives all of that growth. And yep, you guessed it, it's another famous irrational number.
You might have seen this formula before. This is what you use for continuous growth. And that little letter E right there, that's the star of the show. It's called Euler's number. It's an irrational number, about 2.718. You can think of it as the universe's natural speed limit for growth. It's the base rate for how basically everything grows when it's left to its own devices, and that includes your money. And you can see its power right here on this chart. If you invest $2,000 with simple interest, it grows, which is great. If it compounds quarterly, it grows even faster. But when you compound continuously, when you use the power of E, you get the absolute maximum return possible. That little bit of extra money in your account, it's literally created by the logic of this amazing irrational number. So let's just step back for a second. We started this whole thing looking for a hidden code, right? A secret connection. And now all the pieces are here. We've seen that the real world isn't always neat and tidy and rational. It's actually built on a foundation that is beautifully, powerfully irrational. So there it is, the hidden code revealed. The secret link between a building, a piano, and a bank account is this powerful family of irrational numbers. Pi shapes our circles. The square root of 2 gives us perfect geometry and perfect music. The golden ratio, phi, gives us beauty. And E is the engine that drives all natural growth. This isn't just some random math, you guys. This is the fundamental blueprint of our world.
So you see, these numbers aren't the weird ones. They aren't the exceptions. They are the rules. They describe these perfect, elegant truths about our universe that our simple fractions just can't handle. So the only question left is, now that you know the code, where are you going to see it next?